Let's start the video. In this session, we are going to learn about the UART and its applications and frame format. And first of all, what is UART? UART stands for a Universal Asynchronous Receiver-Transmitter, and it's a serial communication protocol. And asynchronous means that UART does not use a clock signal to synchronize the data. Instead of that, it uses start bit, stop bit, and baud rate to align. It means there are only two pin TX and RX, and TX pin is used for transmitting the data, and RX pin for receiving. It's widely used in embedded system and automotive application for flashing the issue and like log related things. And this is the frame format of UART. And first it's a start bit, and after that data bit of 5 to 9 bit. Commonly we are using 8 bit, and it's 1 byte. And third one is parity bit. It's used for error detection. And if it's not configured, then we have to select none. And if we want to use parity as even, then we have to configure 1 including parity bit, and 0 for odd. It's count the zeros and ones in the data format, and after that a stop bit of 1 byte, sorry, 1 bit. This is the characteristic of UART. It's asynchronous. It means there is no clock source required, and full duplex. It means RX and TX can be happen at the same time, and it's required only 2 lines, and it's reduce the complex configurations. And generally we are using two baud rate 9600 and 115200. And for error detection we are using parity, or if we want we can use a CRC checksum on top of data byte. There are some advantages and disadvantages of UART. And for advantage, it's a simple and widely supported in embedded system, and it's only 2 pin RX and TX, and 1 pin is used for ground purpose. And generally we are using for debugging purpose and flashing and log. And there are some limitation of UART, like it's a point to point. It means we can connect only one device. One is RX and one is TX. It means it's change its state like RX and TX and RX. It's comparatively slower than I2C and SPI. And if any error happen in the frame format, it will not correct itself like can. And it's sensitive to baud rate. Generally, if we configured RX as 9600 and TX as 115200, and it's not able to communicate between them. And what is the application of UART? UART is used for debugging purpose, firmware update, and communication with GPS, GSM, Wi-Fi, Bluetooth. And in automotive, we are using automotive diagnostic like OBD and K-line, and IoT device configuration. And if you want to in-depth videos related to automotive and embedded, please subscribe to my channel. Yeah, and let's let's check how our MCU will communicate with our PC using UART communication protocol. And I am using STM32 board and STM32 cube ID. First we have to create a new STM32 project. It's taking some time to open, and need to board selector, and I have to select my board STM32F407 discovery board. And I have to write the project name, like I am using UART TX, and finish. I don't want to initialize all peripheral in default mode, and I am selecting no. Yes, it's open pin configuration, and we have to check analog, connectivity, and there are number of communication protocols like CAN1, CAN2, I2C2, I2C3, SPI1, SPI2, SPI3, UART4, UART5, USART1, USART2, USART3, and 6. These are the communication protocol, and I am using USART2, Universal Synchronous Asynchronous Receiver-Transmitter, and we have to select asynchronous here. Yes, we need to configure GPIO, and GPIO we are here it's configured PA2 and PA3 for USART2, and we can change its direction also, like we have to select, it's already green, it means configured for TX, and we can select and unselect here PA2 for USART TX. We can select from here, it's configured for TX, and after that we have to select PA3 as RX, it's already selected, and the most important is NVIC setting. It means we have to enable the global interrupt. In parameter setting, you have to select baud rate and the data format. I scroll up properly. Yes, its baud rate is 1152, and we can change it as 9600, and we are using word length 8-bit. We can use also 9-bit. And parity is none. I am using parity none, and we can select even or odd as per our requirement, and stop bit is 1, and direction we can select either it's receiving only or transmit only, we can select, and I am using TX and RX here, and sampling we can select 16 sample and 8 sample. These are the basic configuration we have to configure, and Control S for save this code to generate the course. Yes. Yes, it's generated my code. Here you will get all the things. Start in it like 1. Yes, it's configured like USART2, baud rate, and length, stop bit, parity is none, and mode is TX and RX. Like that we have configured, and sampling 16 we configured, and we have to write code here for sending the data. This is the handle. We have to pass this handle to the transmit function, and it will send the data to our PC. And one more thing, always remember, it's write user code began here. It means you have to write your code in between them. If you are so all the pin configuration has been done, and let's start our code. Everything is initialized. User code began here. We have to write in between here. Where it says that like I have to write welcome to Easy Embedded. And we have to pass this message through our UART, and we need to call UART from here. HAL UART transmit, and pass the handle. Press up UART to, actually it's USART. That message P length and after that delay. Just suppose I am using 10 milliseconds and close this bracket, and I have to provide delay of 1 second. All delay. Let's build and check. I'm getting one error. Okay, I have to add a string.h. So actually I have to pass this value. Okay, zero error, zero warning, and I need to flash this code to my STM32 board. And you need to check device manager and check the COM port, which COM port is connected. Here CP210 USB to UART, it's COM 8. Now we have to open PuTTY serial and COM 8, and baud rate is 115200. Yes, welcome to Easy Embedded. It's printing now. Now let me show you the connection diagram. In this session, we learn about how MCU send data to PC using UART. For second part, we are going to learn about how we can send the data through the terminal to the MCU. And thanks for watching, and subscribe for upcoming videos. And thank you all.